watching this video clip. Welcome back to financial management. We're going to look at semi-annual and other compounding periods at this time. In almost all of our examples thus far, we have assumed that interest is compounded once a year or annually. This is called annual compounding. Suppose, however, that you put $100 into a bank which states that it pays a 6% annual interest rate, but that interest is credited each 6 months. This is called semi-annual compounding, twice per year, right? How much would you have accumulated at the end of 1 year, 2 years, or some other period under semi-annual compounding? That's a question. Note that virtually all bonds pay interest semi-annually. Most stocks pay dividends quarterly, and most mortgages, student loans, and auto loans require monthly payments. Therefore, it is essential that you understand how to deal with non-annual compounding. First thing we look at is now type of interest rates. Compounding involves types of interest rates: nominal rates, abbreviated INAM, periodic rate, abbreviated IPER, and effective annual rates, abbreviated ER or EFF percent. First look at nominal or quoted rate, right? This is a rate that is quoted by the banks, brokers, and other financial institutions. So if you talk with a banker, broker, mortgage lender, auto finance company, or student loan officer about rates, the nominal rate is one he or she will normally quote you or tell you. However, to be meaningful, the quoted nominal rate must also include the number of compounding periods per year. For example, a bank might offer 6% compounded quarterly on CDs mean certificate of deposits. Our mutual fund might offer 5% compounded monthly on its money market account. The nominal rate on loans to consumers is also called the annual percentage rate (APR). For example, if a credit card issuer quotes an annual rate of 18%, this is a this is the APR, annual percentage rate, right? The nominal rate is never shown on a timeline, and it is never used as an input in a financial calculator unless compounding occurs only once a year. If more frequent compounding occurs, you should use the periodic rate as discussed below. Periodic rate now, IPER, this is the rate charged by a lender or paid by a borrower each period. It can be a rate per year, per 6 months period, per quarter, per month, per day, or per another time interval. For example, a bank might charge 1.5% per month on its credit card loans, or a finance company might charge 3% per quarter on installment loans. We find the periodic rate as follows. I per equal what? INAM divided by what? M. Meaning nominal rate is the rate for the year divided by what? The number of periods. Which implies nominal annual rate, which is IM, equal periodic rate divided. Now, nominal rate, which is INAM, would equal to what? Periodic rate times what? M. M is the number of periods, right? Here, INAM is the nominal annual rate, this one, and M is what? Number of compounding periods per year. To illustrate, consider a finance company loan at 3% per what? Quarter. The nominal rate, INAM, would be equal to periodic rate, which is 3% times what? 4, which is the number of periods per year. As we give you what? 12%. Alright? As we get INAM. Now, if you have the INAM but you want the periodic rate, it's the opposite. You have to divide INAM by what? The number of what? Periods. In this case, 12% divided by 4 equal to what? 3% per quarter. If there is only one payment per year, or if interest is added only once a year, then M equal 1. And the periodic rate is equal to the what? Nominal rate. Alright? The periodic rate is the rate that is generally shown on timelines and used in calculations. Alright? To illustrate now the use of periodic rate, suppose you invest $100 in an account that pays a nominal rate of 12% compounded when quarterly. How much would you have after 2 years? So this 12% is nominal rate, right? Now first thing you'd have to do is to find the what? You have to find the periodic rate, right? Now the equation here, the for compounding more frequently than annually, we use the following modification of the equation, right? So they end up with something like this now. FV equal PV 1 plus I per raised to the number of what? Periods. Which is really PV 1 plus I num divided by M, because I per is equal to I num divided by M, and then raised to the what? Mn. Alright. So therefore you have to find the I per first before you do anything else. Now in this case now the nominal rate is what? 20%, which is I num. Good? And the number of periods is what? Quarterly, which is you have 4 quarters in a year. That's all. Therefore, to find I per, you have to divide the 12% by what? 4, you get what? 3%. So your I per is what? 3%. Good? And then now, you're going to have to multiply the number of years by the what? Number of periods, which is M times what? N. Which is good if you, will give you the number of periods in total. And that will give you what? 8. Good? So to get there, let me put this right now. So Mn now would equal to 4 times what? 2. The 4 is represented by the M, and 2 is the what? Number of years. Good? Alright. Now the future value now would be equal to $100, 1 plus 0.3 raised to the 8th power. So it will be really 1.03 raised to the 8th power. 1.03 raised to the 8th power, that give you 1.26. 1. This would give you 1.2667. Then you multiply that figure now by 100, you get 126 point. This should actually be 68, not 28. Alright, 126.68. Sorry about that. Okay, so that's how you do the calculation for. So which were, it could be semi-annual. If it was semi-annual compounding, you'd have used what? 2. Yeah, divide 2 and multiply 2 years by what? 2. Should have been 2 periods. So the 4 represent the number of periods. Remember that, please. If I were you, I pause the video, go through again, and listen to what was being said, read through as well, and understand what is being said. Alright? Good? Focus, please. Alright? Next type of rate is effective annual rate, or EFF. This is the annual rate that produces the same result as if we had compounded at a given periodic rate m times per year. As I said, the equivalent effective annual rate. This is the annual rate that produces the same result as if we had compounded at a given periodic rate m times per year. The EAR, also called EFF, for 50% is found as follows: 1 plus I num divided by m raised to what? Remember, m is what? Number of periods. In the EAR equation, I divided by M is the periodic rate. And M is what? Number of periods per year. For example, suppose you could borrow using either a credit card that charges 1% per month or a bank loan with 12% quoted nominal rate that is compounded quarterly. I was saying to the question is how should you which should you use? So let me go again. In EAR equation, I num divided by M is the periodic rate, alright, and M is what number of periods per year. For example, suppose you could borrow using either a credit card that charges 1% per month. That would mean that there are 12 periods, right? Or a bank loan with a 12% quoted nominal interest rate that is compounded what quarterly, which is 4 times per year. Which would you choose? To answer this question, the cost the cost rate of each alternative must be expressed as an EAR, as an effective annual rate. Alright, let's look at it now. So is credit card loan EAR equal 1 plus 0.01 because 1%, right? 12 minus 1.0. Alright, and that will give you 1.0 raised to the 12 power minus 1.0, and then you'd have 1.01 raised to give you 1.126825 minus 1, and that will give you 0.126825 times 100, you get 12.6825%. Alright, good, let's go. Bank EAR now is 1 plus what? 0.3. You add 0.3, the 0.03 because it is 4 periods, you divide 12 by 4, you get the 3%. Alright, the rest of the fourth power minus 1.0 equal 1.03 raised to the fourth power, which would be 1.125509 minus 1. That will give you 0.125509 equal 12.5509%. Now, thus the credit card loan is slightly more costly than the bank loan. This result should have been intuitive to you. Both loans have the same 12% nominal rate, yet you would have to make monthly payments on a credit card versus quarterly payments on the bank loan. The EAR rate is not used in calculations. However, it should be used to compare effective cost of rate of return on loans or investments when payment periods differ, as in the credit card versus the what? Bank loan example. This is just for what? Comparison purposes. Alright? Go again, look at the calculation. So as I said before, the 4 is what? In this case, it will be quarterly number of periods at 12 months. Alright. Look at fractional time periods now. In all examples used thus far, we have assumed that payments occur at the beginning of periods, but not at the same date within a period. However, we often encounter situations that require compounding or discounting over fractional periods. For example, suppose you deposit $100 in a bank that adds interest to your account daily. That is, uses daily compounding and pays a nominal rate of 10% within 360 days a year. How much will be in your account after what? 9 months. The answer is 107.79. $107.79. How do we get that answer, by the way? Let's look at it now. So the periodic rate would have been 10%, which is nominal rate, divided by what? 360 because what? For the because 360 days in the year. And that will give you 0.0002778 per day, right? The number of days now would have been because it says how much is it after 9 months? 9 months, if you divide 9 by 12, you get 75%. So 75% of 360 will give what? 270. So the number of days is what? 270 days. The 0.75 above is really 9 months, 9 months divided by 12 months, based on the example above that is. Ending amount would be equal to $100, yeah, 1.000277 raised to the 270. Why you get the 1.00 is because it would have been 1 plus hyper. And the hyper is what? 0.002778. So it'll be 1.002778 raised to the 270. And that will give you, when you'd have raised this to 270, when you raise 1.002778 raised to 270, you get 1.0778 times 100, you get 107.79. Alright? That's why you get that answer right here. Good? So this is about what? The daily cycle. So 360, the first thing you have to do, you divide what? Percent. Nominal rate to get the hyper. That is just a given in this case. Alright? That was what we call it now. That was daily compounding. Alright? We got monthly, annually. So monthly compound would have been used, you'd have used 12. You divide 10 by 12 in that case, if it was for monthly compounding, because 12 months per year. Alright? Now, last one look at now is continuous compounding. Interest is sometimes compounded continuously as m, number of times interest is compounded, approaches infinity, we get continuous compounding. And the term 1 plus I over m raised to the mn approaches what? E to the I to the n, where E is approximately 2.712828. Therefore, the future value at the end of n years of an initial deposit, present value, where interest is computed continuously at a rate I%, would have been calculated as follows. FV equal PV. I put in the E, right there, which is 2 point raised to the what? 0.08 to 3. And 3 mean what? The number of years. And the 0.08 mean what? 8%. Alright. You get 0.24, raise this to 0.24, multiply it by 100, you get 127.12. And that's the end of that. Alright. Pause the video, look at it again. Remember the 0.08 is what? Percent. And the 3 represent the number of what? Times interest is compounded for the year. Alright. Good. So 3 is the number of, sorry. M, in this case the I is what? Interest, and N is the what? The number of times per year that interest is compounded in this case. Alright. N is the number of years that is, I should say. Alright. Thank you very much for watching. Do have a wonderful day. Look forward for the worksheets to complete.